You've probably done it hundreds of times today without noticing. You're telling a friend about your weekend. Your hands move. You explain how big the fish was. Your hands spread apart. You describe someone taking a left turn. Your finger points left. You say, I have absolutely no idea. Your palms flip upward. Now try something. Hold your hands completely still, not in your pockets, not behind your back, right in front of you. Now explain how to make a peanut butter sandwich, or tell someone how to get from your house to the nearest grocery store. It's surprisingly difficult, isn't it? Your words suddenly feel slower. You hesitate more. You search for sentences that normally come effortlessly. Most people think we move our hands because we're trying to help the other person understand us. That seems obvious. After all, if you're describing a spiral staircase, drawing circles in the air makes your explanation clearer. If you're talking about something tiny, pinching your fingers together gets the point across instantly. Gestures look like visual subtitles for speech. Makes sense, except for one small problem. People still gesture even when nobody can see them. In one experiment, researchers asked people to explain directions over the telephone. The listener couldn't see a single movement. The speakers knew that, and yet their hands kept moving exactly as if they were standing face to face. Maybe they simply forgot they were on the phone. That sounds reasonable, until researchers found something even stranger. Blind people gesture, not people who lost their sight later in life, people who have been blind since birth, people who have never seen another human wave, point, shrug, or draw shapes in the air. When they speak, their hands move too. Even more surprising, blind people gesture while talking to other blind people. Think about that for a second. Nobody in the conversation can see anything. There is no visual audience, no body language to interpret, no reason to perform. And yet the gestures happen anyway. If gestures were only for communication, they should disappear the moment vision disappears. But they don't, which means something else is going on, something much deeper. And this is where the story changes, because your hands aren't moving for the person listening. They're moving for you. For decades, psychologists assumed speech came first and gestures simply decorated it. Your brain formed a thought, converted it into language. Then your hands added emphasis like punctuation marks at the end of a sentence. But one by one, experiments began breaking that idea apart. Researchers started filming people while they solved difficult problems, math problems, spatial puzzles, memory tasks. Again and again, they noticed something strange. The hands often moved before the right words appeared, sometimes several seconds before. It was as if the hands already knew where the sentence was going before the mouth did. Imagine trying to explain how to tie a knot. Before you even find the words, your fingers begin twisting invisible rope in the air. Or think about giving directions through your neighborhood. Your hand starts tracing the route before you finish saying, turn left at the traffic light. Your body seems to be thinking ahead of your voice. At first, researchers thought this was just coincidence. Then they tried something simple. They asked people to sit on their hands. Literally. No waving, no pointing, no drawing shapes in the air, just talk. The results were immediate. People paused more often. They stumbled over words they normally knew. They used simpler language. And when the task involved explaining space, movement, or complex ideas, their performance dropped even further. Stopping the hands didn't just change the conversation, it changed the thinking itself, which raises a question that's much stranger than the one we started with. If moving your hands changes the way you think, then where exactly does thinking happen? Is it only inside your brain? Or has your brain been quietly borrowing the rest of your body this entire time? If you've ever tried explaining a difficult idea to someone, you've probably experienced something curious. You're halfway through the sentence. You stop. Your hand starts moving. Then, suddenly, the words arrive. It feels as though your hand pulled the sentence out of your head. For a long time, scientists thought that was just an illusion. But in the early 2000s, psychologist Susan Golden Meadow and her colleagues began uncovering evidence that gestures weren't simply following thought. They were helping create it. In one experiment, children were asked to solve difficult math problems. Some children naturally gestured while explaining their answers. Others barely moved at all. Here's what surprised the researchers. The children who gestured often revealed knowledge they couldn't yet express with words. A child might verbally give the wrong explanation, while their hands silently demonstrated the correct strategy. Their gestures knew something their speech didn't. Imagine that for a moment. Part of your mind can understand an idea. Before the language centers have figured out how to say it, your hands become the bridge between thinking and speaking. And it isn't just children. Adults do exactly the same thing. Researchers have repeatedly found that encouraging people to gesture improves learning, especially in subjects involving space, movement, mathematics, and problem solving. It's as if moving the body gives the brain another workspace to think on. Think about trying to explain how gears work, or folding a paper airplane, or describing how planets orbit the sun. Almost immediately, your hands begin building invisible models in front of you. You're no longer thinking only inside your head. You're thinking in the space around your body. Neuroscientists now know that this isn't an accident. The regions controlling speech and the regions controlling hand movement sit remarkably close together inside the brain. They communicate constantly. When one becomes active, the other often activates too. This relationship is so strong that some scientists believe language itself may have evolved from gestures millions of years ago. Long before humans spoke in complete sentences, our ancestors were probably pointing, reaching, signaling danger, showing where food was hidden, sharing ideas through movement. Speech may not have replaced gesture, it may have grown out of it. Even today, traces of that ancient partnership remain. Watch someone tell a story over a video call after the internet freezes. The other person can't see them anymore, but their hands continue moving. Watch someone talking while walking alone. Nobody is watching. The gestures continue. Even people speaking to themselves quietly while solving a difficult puzzle often move their hands without realizing it. The audience isn't outside, it's inside. And here's where the story becomes even stranger. Scientists have placed people inside brain scanners while they speak. As expected, language regions become active. But so do areas responsible for planning movement. Not because people are actually moving, sometimes they're barely moving at all. Simply preparing to gesture activates parts of the brain involved in organizing thoughts. Your brain seems to treat movement as part of the thinking process itself, which begins to blur a line most of us never question. We tend to imagine thoughts as invisible things floating somewhere inside our skull, finished, complete, waiting to be spoken. But what if that's backwards? What if many thoughts don't exist in their final form until your body helps build them? What if every wave of your hand, every pointing finger, every invisible circle you draw in the air isn't expressing an idea, it's constructing one, and that idea has a name. It's called embodied cognition. For most of history, we imagine the brain as the headquarters. Thoughts happened inside your skull. Your body simply carried out the orders. But embodied cognition flips that idea upside down. It says thinking isn't something your brain does alone. It's something your brain, body, and environment do together. Imagine trying to explain the shape of a roller coaster. You could describe every loop with words, or you could simply trace it through the air with your finger. Your hand isn't just communicating the idea, it's helping you hold the idea. It's becoming temporary memory, a moving sketchpad your brain can use for a few extra seconds. And once you notice it, you start seeing it everywhere. And perhaps the funniest example comes from comedians. Stand-up comedians spend months memorizing every word of their routines. They know exactly what's coming next. Their hands still dance through the air. Every pause, every punchline, every story. The gestures remain. Because by that point, the movements aren't decorations. They're part of the thinking, which means something extraordinary. Every time you wave your hand, point toward an imaginary place, or trace an invisible shape through the air. You're watching a thought being assembled in real time. So, the next time you're deep in conversation, don't stop yourself from moving your hands. Watch them, because they may reveal what you're about to think, just before you know it yourself. The next great idea you have might not begin inside your brain. It might begin at your fingertips. Like, share, and subscribe for more interesting explainers. Thanks for watching.